Hello everyone. Question is 100 kg of R-134 at 200 kilopascal are contained in the piston cylinder device whose volume is 12.33 meter cube. So we can write down mass as 100 kg, pressure P1 it is given as 200 kilopascal, piston cylinder device where volume V1 we have as 12.32 meter cube. The piston is moved now. The volume is one half of its original size, so the V2 will become as one half of V1. This is done such that the pressure of the R134a does not change. So P1 is equal to P2. So we need to find out the final temperature and change in total energy, that is delta U question mark. Now first we can find out the specific volume V1. So V1 is equal to volume divided by mass. It will be coming around 12.322 meter cube divided by 100. So you will get as 0.12322 meter cube per kg. Now we can compare this V1 with the VF1 at 200 kilopascal and VG1. So VF1 you are getting as 0.0007533 and VG1 you are getting around 0.09951. So both are in a meter cube per kg, meter cube per kg. Now you can see that V1 is greater than VG1. So 0.12322 is greater than 0.000, sorry, 0.09951. So we can say that it is superheated. It is superheated. From superheated steam table, superheated. So from superheated steam table, we can find out temperature T1 as 40 degrees Celsius, and we need to find out change in internal energy. So we will get a specific internal energy U1 as 263.09 kilojoule per kg. Now what is the next step we have? The pressure remains constant. So pressure P2 it will be remain constant as 200 kilopascal. Now here volume becomes half. The specific volume will become as half of original given by divided by 2. It will be 0.1232 divided by 2. So V2 specific volume V2 you will get around 0.06161 meter cube per kg. Now here you can see that V2 it is less than Vg, where you can see that V2 it is around 0.06161. It is less than 0.09951, and it is also V2 is greater than Vf. So because pressure remains constant, we are taking that value. So we can say Vg1 or Vg2 it will be same. So V2 0.06161, it is greater than 0.0007533. So V2 it is coming in between Vg2 and it is coming in between the Vf. So next we can say that at state 2 it is saturated liquid vapor mixture. It is saturated liquid vapor mixture. Vapor mixture. So we need to find out the dryness fraction first. So we can use the formula as V2 is equal to Vf2 plus we can say X2 Vfg2. Here you can see that Vg2 minus Vf2. So x2 is equal to V2 minus Vf2 divided by Vg2 minus Vf2. We can put the value V2. We are getting 0.06161 minus 0.0007532 divided by Vg2. We have 0.09951 minus Vf2. We have 0.0007532. Now x2 you are getting around 0.0608568 divided by 0.0991978. So x2 you will get around 0.6134. From that we can find out as u2 is equal to uf2 plus x2 ufg2. This uf2 and ufg2 you can find out at p2 is equal to 200 kilopascal. So it is around 38.28 plus 0.6134 into 186.21. So you will get around 146.46 kilojoule per kg. Now if you draw a PV diagram, you can draw a PV diagram. So this is a constant pressure process. This is superheated steam. It is cooled as 1 to 2 process. So we need to find out the U2 minus U1. And it is a saturated condition. So at P2 is equal to 200 kilopascal. It is liquid plus vapor mixture. So you will get T2, Tsat. It will be around minus 10.09 degrees Celsius. That is our value. Now, change in internal energy we can find out as M U2 minus U1. So U2 we are getting as 146.26. 100 into 146.46 minus U1 value is around 2633.09. 263.09. So we are getting around 100 into 100 into minus 110.6. So we 11060 kilojoule. That is total change in internal energy as it is cooled. Here it is cooled. Volume is one half of its original volume. So uh, you can see that there is negative, so it is a heat rejection process. It is a heat rejection process. Rejection process. So if we repeat this, we can see that we have written all the given data. We found out the specific volume. We compare the specific volume with VF1 and VG1 at 200 kilopascal. So here we are getting V1 is greater than VG1. So it will be a, you can see here V1, it is superheated. So superheated and at state 2, V2 is equal to V1 by 2. That now this is 0.061. It is coming between VF2 and VG2. and from that we found out the Dynamics fraction using the formula Vf2 plus x2 Vfg2. We found out the x2 as 0.6134. Using this 0.6134, we have calculated the internal energy and final state, and finally we got as m into, this is u1, we can say this is a u2 final stage minus initial stage u1. So we are getting 100 into minus 110.6, approximately it will be 11060 kilojoule. This is the final temperature and this is a change in total energy. Thank you.